Advanced Algebra 2, Concept 19 notes, this is part 2. Now we're going to focus on rational exponent equations to solve. So, solving rational exponent equations is a lot like solving radical equations. We're going to isolate that rational exponent expression. So in our first example, we're going to start by subtracting 2 from both sides. Now we want to raise both sides to a power that will give us a power of 1. So remember, when you raise a power to a power, you can multiply. So let's raise it to the reciprocal power, because 3/4 times 4/3 is 1. So we get 2x to the first power equals 8 to the 4/3 power. Now we can rewrite 8 to the 4/3 power as the third root of 8 raised to the 4th power. When we do that, it's easy to simplify that. The third root of 8 is 2. 2 to the 4th power is 16. So now let's divide by 2. So our potential answer is x equals 8. And now let's check it. So 2 times 8 is 16 to the 3/4 power plus 2, and we're seeing if that equals 10. So 16 to the 3/4 power is 8, because the 4th root of 16 is 2, and then 2 to the 3rd power is 8. 8 plus 2 does equal a positive 10. All right, now let's solve x plus 30 to the 1/2 power equals x. So we have our rational exponent expression isolated. Let's just raise it to the power, reciprocal power. So we're going to raise it, the reciprocal of 1/2 is 2. So 1/2 times 2 is just 1. So x to plus 30 equals x squared. I notice I'm going to have a quadratic to solve. So I'm going to move everything over to the right-hand side of my equal sign. And now I'm going to factor. So this will factor as x minus 6 times x plus 5. Setting those each equal to 0, our two potential answers are x equals positive 6 and negative 5. So let's check them both one at a time. So plugging in 6 for x, we get 36 to the 1/2 power equals 6. We're checking that. And yes. And then plugging in negative 5, we get 25 to the 1/2 power equals negative 5. And that is false, because we take the positive rational exponent, which is 5, and that does not equal negative 5. So only x equals 6 is our solution in this example. Let's just continue with some more. Notice that we have 3x to the 1/3 power equals negative 3. So we need to raise each side to the reciprocal power, so to the 3/1, or the 3rd power. That gives us 3x equals negative 27. Divide both sides by 3, so x equals negative 9 potentially. And then let's plug in negative 9. So we get negative 27 to the 1/3 equals negative 3. And then the cube root of negative 27 is negative 3. So the left side does equal the right side. So that solution checks. Now let's try the next one, okay? So we have our rational exponent expression isolated. Let's raise them both to the reciprocal power of 2. So x plus 6 equals x squared. We have a quadratic to solve, so let's get that in standard form. And then I notice that that will factor as x minus 3 times x plus 2. Setting those each equal to 0, our two potential answers are x equals positive 3 and x equals negative 2. So checking those one at a time, we get 9 to the 1/2 power equals positive 3, and that's true. And then we get 4 to the 1/2 power equals negative 2, and that is not true, because we get 2 equals negative 2, which it doesn't. So our only solution is x equals 3. Okay, one more of these to seal the deal. So we have our rational exponent expression isolated. Let's raise both to the reciprocal power. So x plus 2 equals, and then that's the third root of 8 raised to the 4th power. Third root of 8 is 2, to the 4th power is 16. Subtracting 2 from both sides, our potential solution is x equals 14. So if we plug that in, we get 16 to the 3/4 equals positive 8, and that's true, because the 4th root of 16 is 2, and 2 to the 3rd power is 8. Now let's solve some radical inequalities. Now you can see in bold above, I said, in your final answer, be sure to include any domain restrictions that you need to keep the root a real number. So our directions say solve the radical inequality. We'll solve it almost like we do a radical equation. In our answer, we will look out and see if there's any domain restrictions that we need to include. And that would be any domain that would get our radical so that we are taking an even root of a negative number. Let's just look at number 1 and start. So we need to isolate that radical expression. So we'll start by dividing each side by 3. We get the square root of x minus 1 is less than or equal to 4. We'll just continue as if it were an equation. So we will square both sides to undo that radical expression, that square root. So we get x minus 1 is less than or equal to 16, and we'll add 1 to both sides. So this says that our solution set is all of the values that are less than or equal to 17. But if we look at our original problem, notice that we have an even root. We want real number answers. So as soon as the expression underneath the radical becomes negative, then we will have a non-real number, an imaginary number. So we need to stop our x's at the point where we get 0 underneath the radical. So I can see that as soon as x equals 1, then that is my tipping point. So that means that I need to, x should not equal, or actually it can equal 1, but it should not equal anything less than 1. So I need to put a stipulation on that my solution are all the x's that are in between, and they can include 1 up to 17. So you just have to look and see, do I have an even root in my original problem, and what value will make that 0? And then I have to stop it at that point so that I don't get negative. So in our second example, let's start by adding the 3 to both sides. So 2 square root of x is greater than or equal to 6. Then we'll divide by 2. We get the square root of x is greater than or equal to 3, and then squaring both sides to undo that square root. So x is greater than or equal to 9. Now, if I look up in my original, it is fine to leave my answer as all the x's that are greater than or equal to 9, because I have no potential to get a expression underneath my square root that is negative. Now, finally, notice I have a cube root here. So cube roots, you can take the cube root of a positive or a negative number and get real number answers. So we do not have to worry about at the end limiting our domain. So we'd start by dividing by 4, and then we're going to raise each side to the third power. So x plus 1 is less than 8. X is less than 7. And again, we do not need to worry about limiting to our domain, because we can have values that are negative, because the cube or any odd root of a negative number is simply a negative real number. All right, that concludes the notes for Concept 19, solving rational exponent equations.